and welcome back to a video series on MAT 1033 Intermediate Algebra. My name is Sean Perry. This is video number 21 in the series, Graphing Linear Inequalities. So in this section, we are going to combine the concepts of a line in two dimensions with x's and y's, and inequalities that we've been working on for the last couple videos. So let's consider an example. Let's consider all of the different x and y's whose sum is greater than or equal to 1. Now, if this had been an equality, we might be looking at a line of values whose sum is exactly 1. But now we're looking at an inequality. So we are looking across the whole plane for all the combinations, all the pairs of numbers whose sum is greater than or equal to 1. Now, before we get started on this, let's just note that many numbers are going to work, right? 3 and 4, definitely bigger than 1, but also -2 and 3 have a sum equal to 1, which counts. And there's going to be many that don't work. For example, notice that the origin 0, 0 doesn't work, because 0 plus 0 is 0, and that is definitely not greater than or equal to 1. Right? If this slash is uncomfortable, just think that if I said 0 is greater than or equal to 1, you would tell me that is a false statement. You would not agree with that, I hope. Now, how should we depict this set of solutions to the inequality? So we have the idea of the coordinate plane, and what we've done before is we marked a line on it that solves an equality. Now, instead of trying to mark a bunch of lines, we're just going to shade the whole region of the plane that satisfies the statement. So let's first consider the equality part of this. Let's figure out what we call the edge case. That would be x plus y is equal to 1. Just to get this graphed easily, let's solve this for y and put it in y equals mx plus b form. That would say y is equal to negative x plus 1. So this is a line with a slope of -1 and a y-intercept of 1. We could graph that. It would look like this. Now, we saw before that the origin 0, 0 did not satisfy this inequality. So when we go to shade these two regions, notice that the graph is sort of cut in half by this green line. There's a half over here and a half over here. It turns out that we really don't have to check anything more than 1 point on either side. 3, 4 is over here. We found out that worked. But also 0, 0 is over here, and we found out it didn't. So what that means is we're just going to want to shade on the side that has 3, 4 and not on the side that has 0, 0. Here, I'm not going to try to fill in the whole thing. I'm just going to draw some cross-hatching to show that I've shaded. And so this half of the plane, any point over on this side will work and will satisfy the original inequality. Now here we used a solid line to draw our border. For strict inequality, where we don't want to include the equals part, we use a dotted line to show we're omitting the line that marks the two half planes itself. So for strict inequalities, this is a non-strict inequality with an equal sign. For strict inequalities, we use dotted lines. Let's consider this example. Y is greater than 2. So if I know from context that we're talking about the xy plane here, I don't see any x's. Well, yeah, but remember what a y equals a constant looked like. Y equals a constant was a horizontal line. And so now I'm really talking about, just what side of this dotted line should I have? Well, consider 0, 0. That has a y value of 0, and 0 is not greater than 2, so we wouldn't shade over here. We'd shade on the other side, where there are things greater than 2 for a y value. Honestly, that's it. That's all there is to this one. You have all of the equipment needed to solve this just with those little nudges. So try these praxis exercises, give this some practice, pause the video at this time, and see if you could actually graph the following. Okay, let's see how you did. So to start with y is greater than or equal to 2x plus 1, let's start by drawing the line y equals 2x plus 1. That goes through 0, 1, and it goes over 1 up 2 to get my next point, connect them, and draw a line through it. This includes the equal sign, so we're going to want to draw this as a solid line here. And then which side should we shade on? So let's pick a test point. I've picked the origin. If we plug in the origin, we get a false statement. We get 0 is greater than or equal to 1, but it's not. So we don't shade on this side. We shade on the other side instead. Here's what that looks like. Notice I am omitting the side that has 0, 0. I shade on the other side. That's it. Okay, let's take a look at minus 3x plus 6y is less than 12. I think it would be easiest to graph this if we got it in y equals mx plus b looking form. So let's add 3x to both sides, divide by 6, and we wind up with y is less than 1/2 x plus 2 when we distribute that 6 into both terms. This is strict inequality, so I would graph it as a dotted line. This is the line y equals 1/2 x plus 2, but we don't want to include that when we shade, so we indicate that with a dotted line. Now we're going to want to evaluate a test point. 0, 0 is again not on this line, so it makes a good test point. You might notice that I use 0, 0 as a test point a lot. That's because it's pretty easy to multiply by 0. When we evaluate 0, 0, I get that 0 is less than 2. Hey, yeah, that is true. So we're going to want to shade on the side that has 0, 0 in it, and that's this side down here. Last but not least, let's solve negative 4x is less than 8. So let's solve it for x. That means dividing by minus 4. And don't forget that also means flipping this inequality. And so we get x is greater than negative 2. So think about what x is equal to negative 2 would look like. It would look like this vertical line at x equals minus 2. It goes through all the points that have an x value of negative 2, including negative 2, 0, the x-intercept, I guess. We always use dotted lines when we're dealing with strict inequality. Now we just have to decide what side to shade on. And you might look at this and say, oh yeah, it's the x is greater than that, so I'm going to shade on the right. Yeah, that's true. That is true. But let's look at a test point kind of thought process here. What if I plugged in minus 1, 0? There's nowhere to plug a y in, but that's okay. We just replace the x value with minus 1. And is minus 1 greater than minus 2? Yeah, it totally is. So we want to shade on the side that has the test point. So that looks like this. Any point that's in this half plane is going to satisfy the original expression negative 4x is less than 8. Okay, that's it for this video. Thank you very much for your patience. Have a great day. Good luck with your studies, and I'll see you in the next video.